All right, so we have a probability mass function here. Let's take my pen here. All right, 1 over 30x squared for the values of 0, 1, 2, 3, 4. This otherwise means any value which is not in this range from 0 to 4, the probability of getting it is 0. All right, so the verse prove that this is a probability mass function. Right, so we start with the solutions. First one. Okay, so we can make a discrete probability distribution. But first, let's get our probabilities. All right, when x equals 0, so we have 1 over 30 times 0 squared. When x equals 1, 1 over 30 times 1 squared. When x equals 2, we have 1 over 30 times 2 squared. When x equals 3, and here we have x equals 4. Right, so 0 squared is 0. 0 times 1 is 0. 0 over 30 is 0. 1 squared is 1, so we have 1 over 30. 2 squared, that's 4, so we have 4 over 30. 3 squared, that's 9. We have 9 over 30. 4 squared, that is 16, so we have 16 over 30. All right, so if you add 1 over 30 plus 4 over 30 plus 9 over 30 plus 16 over 30, you will get 1. All right, because 1 plus 4 plus 9 plus 16, that is 30. So you get 30 over 30, that equals 1. All right, so let's make our probability distribution table, since we have the values now. So we'll say here for x and each probability. When x equals 0, the probability is 0. When x equals 1, the probability is 1 over 30. When x equals 2, the probability is 4 over 30. When x equals 3, the probability is 9 over 30. When x equals 4, probability is 16 over 30. Right, so adding all of these up, you get 1. So we've already shown that it is a probability mass function, because to show something, if something is a probability mass function, the key is the summation of the probabilities must equal 1. And when you add these, they're all going to equal to 30 over 30, which gives us 1. So we've done part 1. All right. So you show it like this: summation of the probabilities. All right. So in a formal way, you should have to show it like this: 0 plus 1 over 30 plus 4 over 30 plus 9 over 30 plus 16 over 30. That's how you formally show that it's a probability mass function. Now we go to question 2. All right. We have to find the probability that our random variable is greater than or equal to 1 and less than or equal to 3. So basically the probabilities we're asking for that our random variable is less than or equal to 1 greater than or equal to 1 and less than or equal to 3. So this includes the probability of a random variable being 1, because it's greater than or equal to 1. Our probability that a random variable is 2, and the probability a random variable is 3. Okay? Because it's less than or equal to 3. So the probability of a random variable being 1 is 1 over 30, plus the probability of a random variable being 2 is 4 over 30, plus probability of a random variable being 3 is 9 over 30. So we can add up. All right. 9 plus 1, that's 10. So we get 14 over 30. So that is our probability. 14 over 30. We can even simplify this fraction. 2 divided by 4, that is 7. 2 divided by 30 is 15. So we can simplify it to 7 over 15. All right. The next one, the probability that our random variable is less than or equal to 3. All right. Less than or equal to 3. All right. So this includes the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3, because it's less than or equal, as you can see, less than or equal to 3. So just like in the previous question, you have 0 plus 1 over 30 plus 4 over 30 plus 9 over 30. And again, you still come to 14 over 30, which can be simplified to 7 over 15. Then the fourth one, the probability that a random variable is less than 2. So less than 2 is the probability of 0, the probability of 1. Alright, because these are less than 2. The probability of 0 is 0. Probability of 1 is 1 over 30. 0 plus 1 over 30. That's how we get 1 over 30.